the world is in fact pixelated, quantized, and if time is quantized, then I think it's more likely that we would be in a simulated universe than not. Now, the physicists, the first part, they kind of agree, yeah, there's a minimum distance. We can't really mention it. We can't really measure anything below it. The second part is still an open question. Like, is time, is there a minimum time we can measure? And so that's an open question. But if it was, that would be a clue that, in fact, we are in some kind of a simulated type of universe.
Guys, if you're still watching this video and you haven't yet hit that subscribe button, please take 2 seconds and go hit it right now. Thank you.
But if we're in a simulated type of universe, this is where it ties my brain up a little bit sometimes when I'm thinking about the multiverse and I'm thinking about like simulation. Yeah. These two things can exist together, essentially, you're saying. Because the multiverse is just a bunch of layers of the types of simulations that happen that all may be emanating from one place that's simulating all them. Is that reasonable to say?
Yeah. So, what happened was when I was writing my first simulation book, The Simulation Hypothesis, the basic idea was that physical space is not what we think it is, right. That it's actually a virtual reality, the Matrix idea. And during that process, I interviewed the wife of Philip K. Dick.
So, shit.
Yeah, so she's still alive, and she's,
Today even?
Wow. I mean, she's older. She was, I think, his fourth wife, I think, in the 70s.
Well, he didn't get it wrong on the first three. It's all right.
Right, but and she wrote a book about his life, and so I interviewed her as part of my research because there's a famous clip. In fact, let's see if we can find that famous clip of Philip K. Dick saying we live in a computer programmed reality.
Yeah, I love that you're really into The Man in the High Castle, by the way, because I always ask people about that, and they're like, no, I haven't seen it.
Oh, they haven't seen it? Yeah,
that show was like a little bit ahead of its time based on the Philip K. Dick novel, but it was, what a mindfuck.
Yeah.
Anyway, okay, let's get this on.
Let's see if we can get that.
Is a topic which has been discovered recently.
Well, this is sort of a long clip, right? How long is it?
It's like 4 minutes.
Okay, there's a point at which he starts talking about, see if you can find maybe a shorter version where he's just talking about the computer
114,
reality.
A Glitch in the Matrix?
Yeah, this one might be one.
Philip K. Dick, creator of Minority.
Okay, right there, yeah. Here we go.
The title of my address is, If You Find This World Bad, You Should See Some of the Others.
Le titre de mon discours sera...
The subject of this speech is a topic which has been discovered recently and which may not exist at all. I may be talking about something that does not exist. Therefore, I'm free to say everything or nothing.
Le sujet de ce discours est sur quelque chose qui a été découvert il y a quelque du temps.
We are living in a computer-programmed reality.
Okay, it stopped there. And this was actually, I think...
And by the way, if that was copyrighted and you guys didn't just see it, we just watched Philip K. Dick essentially get real dramatic and then look out at people and say, you're living in a computer-generated program reality. Right.
Now, what he actually said, if you listen to the rest of that clip, so he said, we are living in a computer-programmed reality, and the only clue we have to it is when some variable is changed. Some alteration occurs in our reality. And then he goes on to say, and I interviewed Tessa, his wife, because, that's a famous line that he put out there. But she said, well, look at the rest of his speech. So I went and looked at the rest of his speech. And his next thing he says after that is, you would have the sense of kind of replaying the same scene over and over again.
Deja vu.
And he actually uses deja vu in the term. Yeah. He says, deja vu could be a sense that I've said these same words before. I've been in the same place before. And if you read the rest of the speech, he actually says what he believes is happening is that there are some people outside of the simulation who are fiddling with variables, and they will rerun the variable. Like they will change something in the past, and they will rerun the timeline to see what would happen. And the most famous example of this is what you just mentioned, The Man in the High Castle.
Yeah.
So for those who haven't seen it.
Yeah, please explain the outline for people. It's such an insane plot. Like, I can't believe people didn't get into this.
Yeah, well, when he was alive, that was his most well-received novel. It won like all the science fiction awards. But he really became famous when Blade Runner came out shortly after his death in like 1982, I think it was, or 84 is when the movie finally came out. But in The Man in the High Castle, it's about an alternate timeline where Germany and Japan, the Axis powers, won World War II. And so they divided America between them. And so when he wrote it, he said he did it based on fragmentary memories of this alternate police state. And if you watch it, you can see like the Nazis rule New York. And
Oh,
the
yeah,
whole
it's
East,
wild.
and the West Coast is ruled by the Empire of Japan. Yeah, it's a crazy alternate reality.
They nuked DC in like 1945, like crazy shit.
That's right. There's this entire timeline that it's based on, right? And the H-bomb is actually the Heisenberg device. So there's a lot of really interesting things in that series, which, by the way, Tessa said she thought, as an aside, she thought he would really like it.
Oh, really?
And
Wow.
I asked her, what would he think of The Matrix? You know, because he died in the 80s. And she said, well, two things. First, he would like it. He would say, I love that. This is great. And the second thing he would do is say, call his agent to see if he can sue these guys for stealing his ideas.
That's probably fair.
Yeah.
He was the shit he could come up with.
Yeah, he was way ahead of his time, right?
Yeah.
Because back then, most science fiction was just, outer space colonization. All the famous sci-fi writers of that era were talking about planets, and he's talking about things that happen to us. And usually he was concerned with two big topics, one of which is what is real and what is not. Is this real? Yeah,
That's right.
Oh, your cup says right there, your mug. And the second is does it mean to be a human versus, say, an android or something else. And so in that speech, he talks about that his novels have these multiple counterfeit realities. And so eventually he came to believe that The Man in the High Castle timeline, and for people that haven't seen it, there's a guy who can jump timelines in that show. It's worth watching if they haven't seen it.
Yeah.
But Philip K. Dick came to believe that that was a real timeline that actually happened.
Meaning within the context
simulation.
of a multiverse.
Yeah, meaning the context of a simulated multiverse.
Yes.
Meaning that they let that run and they didn't like the outcome. In this case, they meaning the simulators. And then they changed the variables and reran it again. And we are now in the other timeline, one of the other timelines.
But they exist simultaneously.
What
the
does
same time.
simultaneously mean in the context of a computer simulation?
Meaning that where the butterfly flaps its wings, in this case, let's say we win versus Nazis win, you create two tributaries off the river now that move and on the same, time value of space, but on a different timeline, so to speak.
Yes, exactly. But now consider that if they're actually simulated, it could seem as if they're simultaneous, but really one could run. They could decide if they like the outcome, and then they could run the other one because it would still be T equals 1, T equals 2, 1945, 1946, 1947. It would be the same. So time loses its meaning once you consider yourself outside of the simulation. Time only exists within the simulation.
Yes.
And so that's what really got me thinking about this idea of the multiverse as a simulated multiverse, because what it means is we could be exploring different versions of reality and then come back and then decide, just like Philip K. Dick's simulators did. We could decide, you know what, that one didn't lead to an optimal outcome. Let's let this one run further.
Wait a minute, though. Let's back up for a sec because I'm trying to line this up with the actual plot point. And for people who haven't seen it, we'll try to keep you in the loop here so you can follow. But within that show, you have, I forget her name now, but you have the main character who can see these films. They're like time period exactly what they're supposed to be. They're black and white as if they were filmed during World War II, and now it's 18 years later. It's like 1964. She's living in Japanese occupied San Francisco, and she has access to these films that show the films we know in this reality that we have, which is the Allies winning the war. And she's like, holy shit, there's another reality where they could do this. And like you said, there's people within the show who can go between these dimensions. The one guy was like the Japanese cop who could do it or whatever. And the where I get a little held up, though, to make sure I'm following along here, though, is you also had the Nazis at the time fucking around with this technology and creating a portal where they could go in between dimensions. So they are meaning those guys were in this simulated game, but they were within the simulated game trying to go into another dimension of the simulated game so they could make every outcome a Nazi victory.
Right, right. So that I think was not in the original novel. In fact, in the original novel, it wasn't films. It was a book that somebody wrote. In the novel Man in the High Castle, somebody wrote a book about this alternate timeline, which is our timeline. And so, but what happened to him, to Philip K. Dick, was he had some weird experiences. Some people say he was on, too much drugs, but he took some sodium pentothal or something. And he said that he got full memories of this particular alternate timeline. So in fact, he was going to write a sequel to The Man in the High Castle. Tesla told me that he was working on it, but
damn it.
But then he decided he didn't really need to at some point once he got the full memories. And he also said it was a little too, not necessarily violent, but it was disturbing for him to revisit that timeline because America was such a police state in that timeline. So he ended up just forgetting about that project and going on his later novels are a little different. They go into Valis and they go into all these ideas, all these other ideas about reality. So he had a lot of different aspects of his ideas. He was constantly refining his ideas.
Yeah, he was tapped into something.
He was definitely tapped into something, I think. But for me, that speech was the one that really gave me this idea that, if you could just change a few variables, some things might be the same, but other things might not be the same. Mm-hmm. And Tesla said that he actually claimed that he was communicating with these, with somebody that, could be like a part of the simulators.
Did she say how he said he was doing that?
Yeah, not really, but I said, well, what do they look like? And she goes, well, it was hard for her to see. Sometimes it looked like a blur was there. Like he was actually communicating with somebody or something, but she couldn't actually see what they looked like. Because I was asking her, are they kind of like these aliens or what do they look like? And she didn't really see what they looked like necessarily, but she said there was something weird. But she said he also came to believe that like the Kennedy assassination was one where they decided to fiddle with the timelines a bit and they decided to not have him assassinated in Dallas, right, which is where he was assassinated in our timeline. But then he got assassinated in Orlando. So it's like the conspiracy or whatever that was working on assassinating him. Right?
They just changed the location.
They just changed the location. Or in another version, something else would happen that led to a worse outcome than than this particular timeline.
Now, could that, speculating here, could that have been, for instance, like nuclear war?
I think it was. I think that was the worst outcome. Where maybe Kennedy wasn't assassinated or something. I don't remember all the details now, and she didn't necessarily get into exactly what these outcomes were, but that was the idea was that there were these programmers who could change things in the past. And then he also said we would have to find a group of people like him that remembered an alternate present, an alternate timeline of the present, or past, or an alternate past.
Okay.
And back then it was very difficult to find those people. But then with the internet, it became a lot easier. And now we have this thing called the Mandela effect, which, we can go into.
Can you please explain this? Yeah.
So the Mandela effect is when a certain group of people remember a event or a object or a movie that is different from the way that it is today. And so it was coined by a blogger named Fiona Broom. And it's named after Nelson Mandela because some people believe that Mandela got, instead of getting out of prison, he died.
In prison
in the 80s or early 90s. Whereas in our timeline, that didn't happen, right? He actually got out of prison, became the president of, the leader of the party and became the president of South Africa, won the Nobel Peace Prize. And then he died in, I forget what year it was. I think it was 2013 or
something like that. Yeah.
Yeah. And so, a subset of people remember this alternate timeline. And then, she started to find other instances of this. I think it was at one of these Comic-Con type conventions, like Dragon Con, I think it was called, the one they have in Atlanta, where there were a bunch of fans that, with the Star Trek actors from the original Star Trek series were on stage. And the fans remembered this episode. And the guys on stage are like, we never filmed this episode. What are you talking about? And they insisted they could quote dialogue from this episode.
Whoa.
And Star Trek fans, some of them are pretty intense.
They know their shit.
They know their shit, right? And so I always had dismissed the Mandela effect as well. It's just a bunch of faulty memory. The famous ones are like the Bernstein Bears versus the Bernstein. Like if you bring it up, you can see, that it's actually Bernstein Bear. If you just search for Mandela effects.
Mandela effect, Bernstein.
Not even Bernstein. You'll probably see a bunch of them. If you just search for Mandela effect, you'll see images.
Okay. Yeah, let's pull that up. All right. Images. Beautiful. Okay. The Bernstein Bears, the Bernstein Bears.
Yeah. And so the way it is today is that they're the Bernstein Bears. And yet many people remember them as the Bernstein Bears, the S-T-E-I-N.
You know what's crazy?
Yeah.
I vaguely remember them as the Bernstein Bears.
You do? Okay.
Yeah. It's in there floating somewhere around. That's kind of weird.
Yeah, it's kind of weird. And then, another famous one is the line from The Empire Strikes Back, where everyone thinks Darth Vader said, "Luke, I am your father." But he actually doesn't say that. He says, "No, I am your father." Instead of "Luke, I am your father."
That's something that that one I feel like could have been changed in pop culture because so many people just said it. Like maybe it's like the butterfly effect. Someone says it one way one time and that's such a memorable line. It's personal. You're calling out a name. Then people start repeating it. Then suddenly it becomes a pop culture phenomenon and the rest is history. I could see that. Yeah.
Yeah.
But what you're talking about with the Mandela effect is fascinating.
Yeah. And so, I dismissed most of these as like a little memory lapse or a pop culture thing. But then you get into what I call proximity and significance. So meaning if you were close to a particular event or it had some significance in your life, then you're more likely to remember it correctly. And so I've divided them into categories. And some of these that are just like one or two letters different or a movie line that's different, I think they could very much just be people misremembering them from pop culture. But if it's more significant for you, like the Star Trek episode, right, that you've seen, or, many people remember the movie Kazam and Shazam, right, with Sinbad. So people insist there was a movie. In fact, let's look it up. I even forget which one is the real movie. So people thought there was a movie in the 90s with Sinbad in there about a genie called, I think it was supposed to be called Shazam. And people are like, no, I insist. I had the VHS tape and I watched it like many times.
Like a lot of people are saying
like
this?
a decent, still a subset. It's not a majority, but it's a subset. And so if you look at the images, you can kind of see that there was actually a movie called Kazam, I think, if I'm getting the two right. Oddly enough, sometimes it seems like there's weird Mandela effects going on with this. And
Kazam with Shaq. I've seen that movie.
With Shaq, right? But people insist, no, this was a separate movie from Kazam with Shaq. So if you go to the images, you'll see people have drawn, images of Sinbad. And this got to the point where Sinbad actually recorded a scene from this movie that people had described to him in 2017, just for fun.
Oh, just to fuck with him.
Just to fuck with him. To say, people say I was in this movie, but I actually wasn't.
Oh, that's great. Yeah, it's crazy because like also thinking about it on a more micro scale, you have when you look at like trial testimony and what's useful and what's not, they always talk about how eyewitness testimony is actually often the least useful because stories change in our mind and we actually believe we saw things over time, whether it was we were coached to believe that or, we had some traumatic event that we witnessed and you're in such shock that then you play it back and you start to reason your way through it and you start to see things that maybe you didn't. And this to me could be part of a very similar type phenomenon, no?
Some of them could be. And so, again, that's kind of what I assumed originally. And then I had a friend of mine from MIT who was visiting Google. He worked for Google and was visiting me in Mountain View. And he goes, you ever heard of this Mandela effect? Yeah, I heard of it. People with false memories or faulty memories. He goes, well, the best explanation is, some kind of simulated reality. Because if you rerun the simulation, little things will change along the way. And so it gets back to proximity and significance. So if something is significant for you and multiple people remember it that way, then you're more likely to have gotten it right and less likely to have gotten it wrong. So for example, Nelson Mandela, there was this one blogger, I don't remember her name now, but on YouTube where she said that she was a journalism student and she was supposed to go visit Nelson Mandela in South Africa. And she actually went there, but they said he was too ill for her to actually visit him. And so she came back and she started working for NPR, and then she heard he died and saw his funeral and his wife Winnie. And so this is somebody that actually went to South Africa to meet with him. So it was much closer, much more significant. So the Star Trek example is another one. I mean, there are folks whose parents are like evangelical Christians and they really followed the Reverend Billy Graham. And I don't know what year he died, but there's a whole group of people that say that he died. They remember getting the magazine in the mail, like Billy Graham, this is the year he died, many years before he actually died. And so they feel like it's changed. And that's where we get into some real more significant items like scripture. People remember their scripture exactly, right? So if you look at Isaiah in scripture, I mean, there's whole websites dedicated to biblical changes. And if you look at Isaiah, there's the line about the lion and the lamb. If you look at it now, if you look up Isaiah, lion and the lamb, you'll see there's no actual line about the lion and the lamb. It says the wolf will lay with the lamb or something like that.
So this is another, okay. In the Bible, Isaiah 11:6-7 describes a time when the lion and the lamb will live together in peace along with other animals, and a child will lead them. The wolf shall live with the lamb. The leopard shall lie down with the kid. The calf and the lion and the fatling together, and a little child shall lead them.
Right. And so, but most people remember the line of the lion and the lamb.
But they're not together.
And, you know, when you get to scripture, you're in a place where people do memorize things exactly in different religions. And so this is what really got me thinking, okay, is there a possible explanation? And whether you believe in the Mandela effect or not, I think it's a useful way to think about rerunning multiple timelines. And that's where I came up with this idea of the simulated multiverse, that if you rerun the events, some things will be different, just like with the butterfly effect. If you change a few variables, and that really was what Philip K. Dick was talking about. And that got me thinking about what would it mean in a computational multiverse? Could we have memories of a previous run of the simulation, for example, where you remember things happening differently?
When you say like computational multiverse, though, versus in my head, I'm just thinking of like a multiverse where it wouldn't necessarily be a simulation on the other end. What would be, I don't even want to ask that. Like, what would be the main differences in how the multiverse behaves if one's computational and another theory says it's not?
Well, that's a very interesting question. And before we get into that, let me just do one more Mandela effect. And
Sure.
We'll get into what it means to be in a computational multiverse and how is it possible some people might remember something that's done differently. So another one that was most significant, that was very significant, I thought, was the Tiananmen Square. I don't know if you remember that, but there was the guy in front of the tank. They called him Tank Boy. So if we look that up now real quick, and we look up, you know, a picture of Tank Boy,
Where he's just standing in front of the tank.
and what happens? The tank tries to move around him, right?
Yep.
So, do you remember him being run over by the tank or not?
No, I think they got him out of the way. Right?
That's what I remember, and that's what the main timeline says. But there are a number of people who actually remember that he was run over, and they said it was the bloodiest thing they ever saw on TV by the tank. And that is one of those weird, interesting memories that for some people has more significance than other people. And so when we get into scripture or we get into events that might have more significance, is it possible that these people are actually remembering something that was significant to them? So perhaps it's not just faulty memory in some cases. And so I came up with this idea. Could it be that those memories are still there? So when we run a computational, so every program, like if you're running a computer right now, people are probably watching this on their phone or on a computer, there's actually multiple processes running at the same time. But they don't run exactly the same. If there's an actual CPU, what happens is the CPU will run, say, Microsoft Word for a little bit, and then it'll go and it'll run, you know, some other program like Zoom or YouTube for a number of cycles, and it'll go back and forth, but it does it quickly enough that it seems like it's all happening simultaneously. But what happens in computer science, there's this thing called garbage cleaning. So if you're rerunning a process, you may be using the same memory that a garbage collection that you ran before. But what happens is that sometimes the previous values are still there. in memory. And so what garbage collection does is it goes and it cleans up those values and sets them to 0, but it only runs every so often. And so it's possible that you still have values there in memory of a previous run of that same program. And so that's one of the differences when you think of a computational multiverse. If it's using the same kinds of computation, then it's very possible that that's what's going on. Philip K. Dick also, wrote a story that was turned into a movie called The Adjustment Bureau.
That was Matt Damon, right?
Matt Damon and Emily Blunt. And that was based on a story called The Adjustment Team, in which case there's a guy, he goes to work, I think Fletcher was his name, and suddenly he sees that everything's frozen at work. And the adjustment team is like changing things. And then when they start up again, everyone just remembers things as they've been adjusted. They don't remember how it was before, everyone in his office. But he remembers before because he wasn't part of the adjustment. He remembers exactly what the office looked like and how people were dressed, and everything was different. And so, the movie's a little bit different from the book, but it's the basic idea. And so what happened was Tessa said that he went into the bathroom to turn on the light, and he was like trying to pull a chain. If you remember, there's the old chain lines. But instead it was an actual switch. And he said, this is weird. I've been here 100 times. I've done this, this is our apartment. I've done this many times. It wasn't a light switch. It was a chain, or maybe it's the other way around. It was a chain, not a light switch, or it was a switch, not a chain. And she said that's what gave him the idea to write that particular story, is maybe what if somebody's actually adjusting things in the world around us, and then
we're saying,
stop and then rerun it. And so that's what the way I think of a computational multiverse. Now, there's a whole area of quantum computing. So just recently, Google announced a new quantum computing chip. It's called Willow, I think, for example.
Yeah, it was a little scary, that press release.
Yeah. And
Shit could do a lot.
Yeah, and in that press release, one of the folks at Google, I think, said, well, the reason we're able to do this particular computation so fast is because we're using the multiverse, and we're actually computing in all these different multiverses. Now, the basic idea is that in a quantum computer, you can do things much more quickly than you would be able to do them using a standard computer. Certain problems that grow exponentially are very hard for computers to do. And, exponential growth is when a number grows based on the exponent growing, it just grows really fast. And probably the best story or example of a problem like that is the king from India and the sage and the chess game. And so what happens, the king loved to play chess, but nobody wanted to play with him anymore. And there was this sort of wise man, and he said, well, if you play chess with me, I'll give you anything you want if you win. And then the wise sage says, okay, how about this? If I win, you'll give me 1 grain of rice for the first chess square at the bottom of the board. And then in the next square, you'll put 2 grains of rice. And then 4 grains of rice, and then 8 and 16. So he's doubling it each time. So it's like 2 to the power of X. And the king is like, sure, why not? That's pretty simple. But it turns out that if you keep doing that, you get to a very large number. You get to 2 to the 64. And it was like more grains of rice than you could fit, like in all of India, for example.
Yeah.
So that's an example of a computational problem that grows exponentially. And so quantum computing, theoretically, the idea is that it can have qubits instead of regular bits. So regular bit has a value of 0 or 1, right? And like we talked about earlier, just the simplest unit of information, yes or no, 0 or 1. A qubit is a bit that is in superposition. So we go back to what we were talking about earlier, Schrodinger's cat.
Yes.
We said the cat was in superposition, meaning it was both alive and dead. So it occupied both states, a superset of the states. That's where that term comes from in mathematics, superposition. So the idea is if you have, let's say, 2 bits right next to each other, usually the possible number of values is 2 to the power of 2. It's just 4. Or 3, if you have 3 bits, the number of possible values is 2 to the power of 3, or 8, or 16 for 4 bits, right? So those are all now, it's pretty easy for a computer to look at 16 different possibilities and figure out which one works. That happens very quickly. But when you get to these large numbers, like 2 to the power of 64,
it gets
or
hard.
2 to the power of 128 bits, or 512 bits. That takes thousands of years, basically, for the computer to explore every single one of those possibilities.
Does that change if we get to quantum computing, though?
Well, that's the idea, is that eventually in quantum computing, if you can basically put the bits into superposition, they're called qubits, Q-U-B-I-T-S, then you can explore all the values at the same time inside different parallel universes.
What in the technology allows us to do that? Like, can you explain that mechanism?
Well, the mechanism is one that's like, it's a little weird because different companies are doing it differently. But the way they're doing it is that they're trying to put a particle or a molecule or some very small item, a photon, an electron. They're trying to put that into superposition because we know. That's what the double slit experiment was about.
Yeah.
It was about sending through electrons initially, and then photons, and then later they believe that even larger molecules actually exist in a state of superposition as well with probability waves. So it's really weird. Like once you get into this, none of this stuff makes any sense from a common sense perspective. And so the basic idea of quantum computing is that theoretically you should be able to explore all the possible values. Now, theoretically is one thing. Doing it in practice is very hard. And so quantum computing is still like back at where we were in the 50s and 60s. Right? It requires room-sized computers. And one of the problems is that particles get entangled. And when they get entangled, they cohere and they decohere, which means they're errors that pop up. And so if you just try to put one little qubit into a 0 or 1 superposition, and then it comes back to a 1, you could have it basically flip. Like it's kind of like when I was at MIT, we built like computers ourselves, like from the ground up.
What a flex. When I was at MIT, we built computers. Another Tuesday.
Yeah, it was a whole semester thing it took. And it was like this big board and we were like putting wires in things. But what happened was at one point I couldn't figure out what the hell was wrong. Like why wasn't it giving me the right answer? And it turns out there was just some physical problem where some wire got crossed and the value got changed.
Yes.
And so this happens over the internet. Like if people are watching this over the internet, they've got the bits from the server on their computer. How did they know they got the right bits? Because it turns out physical wires are actually error prone. And because if you look at it, if you go way down to the bottom level, a 1 is represented as like 5 volts or 10 volts or some number of volts, and a 0 means like 0 to like 1 volt or something like that. So you've got these values, but they can get easily messed up in the physical world, and that's what happens with quantum computing. So there's a whole series of error codes, correction codes that get put into place. And there was a guy named Huffman, and then there was a guy named Claude Shannon, who's like the father of information theory, who was at Bell Labs and MIT back in the 50s and 40s. And they came up with all these different ideas for how do you minimize the number of errors. And the basic way you minimize errors is you duplicate some information. And you say, okay, here's a string of, let's say, 10 bits. And you just count the number of ones. Let's say there's 3 ones in there. And then you add the number 3 at the end of the transmission. So when you get it, you look at those 10 bits, but you look at the little thing at the end that says there should be 3 ones. And if there's more than 3 ones, you know something's wrong.
Right, yeah.
And if there's something less than 3 ones, you know there's something wrong.
Right.
So then you ask for the bits again. It means something went wrong. And so this has been the problem with qubits in quantum computers, is the physical way they implement the bits has made it very error prone. So you end up having to run like 1,000 times the same procedure to make sure it comes out correct. Because then if you actually run like a quantum computer, people can do this. The IBM, you can like actually go up and literally upload your quantum computing code and have it run, and it'll tell you I ran it 90.
Can?
Yeah, ran like 100 times, and 97 times this is the value I got, and 3 times this is the value I got. So therefore, the 97 is the correct value. The 3 were errors, basically.
Isn't there, and this might be a little bit of a side point here, but it is fascinating to me because we're coming into this brave new world as we see it with technology. But isn't there some serious implications of if certain countries, whether it be us or someone else, got a quantum computer before anyone else, they could effectively take over the world silently without anyone knowing it, and they could set a set of standards such that other places couldn't get to the power of quantum computing that they have?
Well, I think the worry is not so much that. The worry is more that it's not that there aren't quantum computers. The problem is that the number of qubits in those quantum computers is so small that it's hard to do anything useful with them. Like if you think of like the Apple II computer, right? It was an 8-bit computer. So the microprocessor only, dealt with 8 bits at a time.
Mm-hmm.
And so today's qubits, the reason this Google announcement, Willow, was I think had 100 error-corrected qubits, which is the most that anyone has ever been able to achieve. Right? We should probably look that up. I don't remember the exact number, but it was in that range.
Willow 100 qubits or whatever.
Yeah. If you just look at the Willow announcement, and the basic idea is that they were able to run one particular problem like significantly faster.
Yes.
Like exponentially faster. And then the problem is people think you can break encryption with a quantum computer. Once you have enough qubits, basically every secret that's out there has been transmitted more or less digitally.
Yeah.
Banking, Bitcoin, encryption.
That's what I'm saying. The blockchain's fucked with it.
Well, it is eventually, but the way the blockchain protocol works, so let's see, how many qubits was it?
We have it up on the screen.
Yeah.
10 to 25. The fastest number of supercomputers, 10 septillion years.
Well, that's how long it would take to solve this particular. Now, this problem is not a useful problem. This is just like some problem they made up that they can show that a quantum computer runs so much faster than a regular computer. So it would literally have taken like 10 septillion years for a supercomputer to solve that problem that they solved.
I just keep seeing that number in here. I don't see the qubits, but
You might see it somewhere else. Yeah.
The point's taken.
Yeah.
Wait, what's that chart? Years?
What's that chart? That's
No,
years.
that's years
That's more
as well.
years. But so the problem has been like to get 100 error-corrected qubits, you need something like 1,000 actual qubits or something.
105 qubits.
105. Okay.
There it is. Okay.
So that's the actual number that they were able to. So that it was significant because before you had like 4 qubits, 8 qubits. Now if it gets to 512, 1028, which is not that far away, you could theoretically start to break some of the encryption that's out there. But well before Bitcoin broke, you would end up, you could just go to any banking site, right? You could basically break any encrypted message that's ever been sent.
How do you defend against this ahead of time?
Well, what happens is you change the encryption algorithm. And there are certain algorithms that are more quantum safe than others. And so, I wrote an article back in 2017 that got, it went viral at the time. This was during the last Bitcoin boom. And I titled it, How I Cornered the Market for Bitcoin Mining Using Quantum Computer. And it was just a theoretical article. It wasn't an actual.
You blue balls everyone. Okay.
But I discussed how the Bitcoin mining algorithm works. What happens is you get like the transactions and you put them in a block and you create a block header. And then you have to come up with this random 4 bytes. And that is the hard part of the problem. So the way Bitcoin mining works.
And you didn't figure that out.
No, I didn't figure it out fully.
You can tell me. No one's listening.
Yeah, that's right. No one's listening. I laid out a framework for how you might think about solving that kind of a problem where you have some regular bits and some qubits. Now, there are certain algorithms that they think are more quantum safe than others. And one of the algorithms used in Bitcoin mining, some of them say, well, you need 1 million qubits to do it. But turns out that's not true because you need 1 million if they were unerror corrected. But if they're corrected, you need a much smaller number than that. And when I say algorithm, there are these guys who have figured out these algorithms for how to use a quantum computer to do X, Y, or Z. And so eventually what can happen, though, with the Bitcoin protocol is they can change that encryption algorithm to make it harder. Like they've already done this several times. If you go back to the 90s, all the encryption was using like a particular algorithm. I forget what it was.
This is way pre-Bitcoin, obviously.
Yeah, this is pre-Bitcoin. But then later they started using one with more bits. There's like SHA-256,
so
SHA-512.
It could keep trying to get ahead of the curve.
Yeah, and there are algorithms that are quantum safe. So, but the problem is then you would need to, I'm actually a big fan of Bitcoin, so I'm not at all predicting that.
I own Bitcoin too.
That this would be a problem. I was actually involved in helping create some tokens out there, including one called Theta. which is, I think, in the top 50 or so back in 2017, 2018.
Wow.
When we're doing it, it's sort of a distributed network that lets you process AI and videos and other things out
Did
there.
you do the Hawk Tuah coin too, or
No,
that wasn't you?
That wasn't me, and I didn't invest in it.
Okay, good.
People were like, perhaps you shouldn't take your financial advice from a girl called Hawk Tuah.
Look,
That's probably not the best,
I'm not exonerating her, but I mean, if you invested in that,
Yeah.
Darwinism.
Yeah. I mean, what you need to do is figure out, is there a utility, for specific coins versus other coins? And if it's just a meme, I mean, that's basically a meme coin.
It's a meme coin.
And meme coins go up and they come right
That's
back
right.
down. And that's the difference, I think, between Bitcoin and also some altcoins that have some actual utility, like Ethereum. And I mentioned Theta. There's a bunch of Solana. There's a bunch that do have some serious utility.
And you were helping build Theta, you were saying?
Yeah, back when it first got started. It was originally a distributed video streaming network. And then later it became just a distributed processing network. So you can run AI and other things on. There were all these gamers, basically, who were donating their GPU time. So what do you need to run games? You need good GPU.
Yes.
What do you need to run AI? GPUs, right?
Yeah.
It's the same processor that's used like in each of those things.
Where does, I mentioned this earlier, but a book that really just blew my mind and changed how I looked at things was Superintelligence by Bostrom, where effectively that was one of the hardest books I ever read, in the sense that it wasn't enjoyable and it wasn't meant to be enjoyable. It was like, he's a genius. I'd love to talk with that guy sometime, but he essentially laid out every possible that he could conceive of extrapolation of, let's say, like the decision trees of the directions that AI could go effectively.
Yep.
And obviously he worked in some other concepts as well, but like, where does AI marry into like the multiverse? Or are these two separate things that happen to exist on a similar playing field, or are they tied to the same person or entity holding the strings up here?
Well, you can look at it a few different ways. So I got interested in Bostrom because he wrote a paper, even before his book Superintelligence, he wrote a paper in 2003 called Are You Living in a Computer Simulation?
Yeah.
And so he pretty much invented what's called the modern simulation argument. And that argument is actually about AI, it turns out. And so when I mentioned the NPC versus RPG versions of the simulation hypothesis, there's the Matrix version. There's a guy named David Chalmers, who's also a philosopher. Nick Bostrom is also a philosopher. So philosophers clearly like to think about this stuff more than the rest of us. And Chalmers coined the term the Matrix hypothesis back in 2003. And when I was talking to him, he said, well, everybody ended up using the simulation hypothesis, which Bostrom coined first. But his basic idea was that if a technological civilization could get to a certain point, and that point was where they could create AI versions of conscious beings, and you could create millions of those beings, billions of those beings, inside a simulation.
That aren't technically conscious.
Depends on how you define consciousness, but basically he was saying if you add up all the amount of neurons and the amount of information a person has in their entire life, and he was kind of estimating, maybe you could have a big computer. He wasn't even getting quantum computing, right? This was back in 2003. So he was just estimating that if you can have these AI beings, well, then you can have a billion or trillion of them in one simulation very easily, and you can fire up another simulation. What do you need? More server space, right? And with Moore's law, which we mentioned earlier, continues to hold, you're going to get better and better computational process. Cost of compute keeps coming down as well, but also the amount of computation you can do keeps coming down. And I think at the time, Bostrom estimated something like an advanced civilization might take a whole planet and use all the mass of that planet for computation. And they could create lots of simulations. In fact, they could create millions of simulations. And each of those simulations could have basically billions of simulated beings inside them. And so his point was that if any civilization ever got to that point, that they could create all these AI beings and all these civilizations, and these simulated civilizations, then he said, if you are a being and you can't tell the difference whether you're simulated or not, which are you more likely to be in? There's one base reality, let's say X number of beings. There's a billion simulations, each with billions of beings. There's a hell of a lot more of these AI simulated beings than there are people in the base reality.
Right, because they were extrapolated upon. Okay.
Extrapolate.
Yeah.
Or the simplified version, and there's a clip of Elon Musk in 2016, actually, the same year that I was playing ping pong, where he talks about this too. He said, basically, if there's one base reality and there's a billion simulated worlds, then the chances that you're in base reality is 1 in billions.
Right.
Which means if you flip it around, what are the chances that you're in a simulation?
Very high.
Very high, right? A billion minus 1.
I think about this
right?
often. Yeah.
Yeah. So from that perspective, this is where Bostrom's AI work and simulation theory intersect, right? Because and most people don't realize that he was talking about the NPC version, not the Matrix version.
Oh, like you were explaining earlier.
Yeah. Because his logic was built primarily on the number of simulated beings. Well, you can't be playing that many simulated beings necessarily. They would have to be AI. Right. So they would have to be like running in a simulation
On their own without you controlling
Without you controlling them, because in base reality, you couldn't really control unless you had AI doing it for you, in which case it's the same
That's
thing.
what I'm saying. Like, are there things that we can't even conceive here that could possibly make that, like, have a godlike ability on the other end of the simulation to control a billion or a trillion things at once? And for us, it's the same thing as controlling one thing.
Right, but what would that be at that point? It would basically be another AI, probably, right? Or
It might be, yeah.
Yeah, and so I think one of the reasons why I'm interested in simulation theory is because it opens up other possibilities, and so even Bostrom, kind of talks about this. He said that people who are staunch atheists, once they consider simulation theory, they'll say, well, any being that's outside the simulation would appear supernatural to us, right? Maybe they can control 1 million people. Maybe they can have their avatar walk on water, right? There's all kinds of things that could come up that you start to think about differently when you think of an actual simulated reality. And I think that's very interesting because it opens up possibilities that otherwise aren't there in a purely materialistic world, which ties back to, this idea of, did these miracles actually happen, right? Are there people who can be in more than one place, can be at 2 places at once? That could happen in a simulation, right? I can have my avatar potentially, if the code allows it, in 2 different places, but it may be a skill or a level. You may have to be at a level in order to be able to do those types of things.
And that also gets weird when you start putting into terminology like that, because that's all you can do, because we only know what happens here and what we know as humans on this, whatever it is, planet or existence of the simulation. But when we talk about like levels and stuff and use like video game terms, who's to say that that's even how they whoever they are determine it? Because they may have an entirely different set of principles as to how. This is getting a little weird how I asked this, but like. You understand what I'm saying? Like they have a different set of principles as how they measure anything.
That's true. And that's what, for us, I'm doing the same thing that, say, the religions did 2,000 years ago. I'm using the latest techno-scientific metaphors, the latest technology, in order to explain something that could be very complicated and could be even more complicated than we can even imagine. Right?
Jesus Virk has a good ring to it.
Well, I was at this Islamic conference and they were talking about ensoulment. When does ensoulment occur? The same debate we have here about abortion, right? When does the soul go into the fetus? Right. Is it at conception? Is it at birth? Is it somewhere in between? Right. Last trimester. And I said, well, I'd like to give a different analogy for what ensoulment means, which is basically it's the time when you put on the headset that you forget about what happens outside. You forget. So many ancient traditions, not just the religions we have today, but many ancient traditions actually describe this process of forgetfulness. Right? This is something that happens when we incarnate. In the Greek traditions, they say that the soul crosses lethe, the river of forgetfulness.
River Styx is Rome, right?
Yeah, no, it's Greek as well, but
It's
it's
Greek?
one of the rivers that you have in the underworld. Styx is the one you cross to go back, but Lethe is the forgetfulness one.
Got it.
And in the Chinese traditions, you have Meng Po, who's the goddess of forgetfulness, and she brews this tea of forgetfulness. And you drink it, when you die to like forget about everything, but also when you're born as well. And then I mentioned Maya earlier, right, with the story we told.
Illusion. Yeah.
Illusion, but also it's kind of like voluntarily forgetting, right? Agreeing to forget what's in the outside world. And so we've got this thing that happens where we become attached to our body, our character, our avatar. I mean, the word avatar itself, by the way, comes from ancient Sanskrit.
It does?
Yeah. So the guys...
James Cameron didn't tell me that. Damn it.
He didn't tell you that, right?
No.
So a lot of the technology around movies and video games and goes, CGI goes back to Lucasfilm and George Lucas and Star Wars.
Yeah. Mm-hmm.
So at Lucasfilm, they built one of the first MMORPGs. I wouldn't call it MMO. It wasn't really massively multiplayer, but it was definitely a multiplayer online role-playing game called Habitat. And this was back in like the 80s that they came out with this. And you had these 2D characters on the screen, and that was they were trying to come up with a word to represent that, to say that this character on the screen represents me, the player. And so what they said, well, the guys who were in charge of building Habitat, afterwards, they said this. They said, well, it felt like, by the way, they were using Commodore 64s and were using dial-up lines. So it's pretty amazing. They actually got like a full graphic. It wasn't sophisticated graphics. We could even look at the graphics of Habitat. Like if we bring it up, it's just these 2D graphics.
Type in like Habitat.
Yeah, Habitat,
video game or
Lucasfilm. Yeah,
Okay.
You'll see it.
Yeah, it's amazing. Like when you look at graphics now, even from like 07 to today on like NBA 2K or something.
Right.
And where they're at. Oh my God.
Yeah, they're pretty different.
All the way back there.
So now we're going back to the late 1980s.
Do you want the second one right there?
Yeah, the second one would show you like the graphics.
Okay.
So, I
Can
mean,
we
it's
blow
not
that
bad
up, Alessi?
What's up?
Can we blow that up by any chance? I mean, for the 1980s, that's not the worst thing I've ever seen.
Yeah, it's actually pretty good. I mean, those are pretty.
That looks better. Honestly, that looks better than some of the Game Boy Color we were using in like 05 or whatever.
Yeah, I mean, it was in many ways it was ahead of its time. It didn't quite have the 3D perspective, but they said it felt like it was they were a person who's a big person, like, let's say our human size, where they were squeezing themselves into the phone line, and then they were squeezing themselves into this little 2D character on the screen. And they were looking for a term for that. And in Sanskrit, avatar means a divine entity that's very big. Let's say an infinite divine entity that squeezes itself into a human body. So it's like an incarnation of a divine entity. And so they used that term, to be the term. And then Neil Stephenson came out with a cyberpunk novel called Snow Crash in 1992. And he used the term avatar in there for his definition of the metaverse, which was your character. And that basically popularized it. And so now we all, within the entire video game industry, that term is pretty common.
Very, very widely used. Yeah. Even after, like, obviously the movies blew up and everything, but that's something like when Michikaku was in here and was talking about, like, if there were half biological entities that existed on Earth, it could be an avatar of so. And now it gets weird because you're like, so it's half real but half not, but they're still using that term.
Right.
Blows my mind a little bit.
Yeah, and the term is being used a lot now for projections, or like in the movie Avatar, right? He was lying down inside the pod and he was controlling the physical, in this case it was a physical entity of the Na'vi, the blue alien, right?
Now, if we're going to talk about how avatars could exist in our reality, some of this I might be wrong on because you think about this a lot more than I do as far as like what the possibilities of that are. But obviously something that a lot of these things come back to is like NHI. Things that are not from this planet that could potentially visit here or are here or whatever you want to say. And one of my favorite things, I don't know if I should say favorite, but like one of my things, like mind fuck things to think about is if you go through the UFO phenomenon and assume that some of these things did happen. There's people who definitely claim stuff and that's not real. But across, let's even just look at the 20th century and some of the claims, be it 94 in Zimbabwe, the late 40s and early 50s on nuclear bases, stuff like that. If some of these things are real, the question becomes, how could a species so advanced that has obviously been able to tame time and space reality beyond what we know, who in that scenario, I would assume at a minimum would have invisibility capabilities and stuff like that to not be seen, or an ability to, wipe your memory instantly if they decided they were seen by you. Why then would they allow themselves potentially to be seen? And part of it to me is that is a part of their, like, they are simulating, I've always used this word, they are potentially simulating a data set of, okay, we show craft in this town and 10 people see it. That's a data set for us. We want to see, this is an impetus. How do they respond to that impetus? And how does that butterfly effect affect the rest of humanity based on how these stories are told and how it's extrapolated over time? Do you think something like that is possible, number one? And B, could that play into your theory in some capacity, simulation theory?
Yeah, so there is an overlap between the UFO phenomenon and simulation theory. And that's, I think it gets into this area that you're talking about here. I mean, there's different theories of NHI, right? Are they extraterrestrial? Are they time travelers? Are they cryptoterrestrials? Are they a species that's been on Earth for a long time and they're not really extraterrestrial at all? But where the overlap between simulation theory and the UFO phenomenon comes is in this idea of being able to project into physical reality. And so, as I started to think about the UFO phenomenon, I met Jacques Vallée.
Legend.
Yeah, who, was one of the first to come up, along with a few others, but to talk about this idea that maybe they're not extraterrestrial after all. And he called it they're messengers of deception. Maybe they're deceiving us in some way and making it look as if they're extraterrestrials, right? Or maybe they've been here all along. Perhaps it's, if you go back to the stories of the Fae in the British Islands, or you go through some of the mythological creatures in France, or the jinn, which I've spent more time looking into. It's quite interesting. But coming back to this idea of the overlap in simulation, he told me about a couple cases that really got me thinking. And one of them, he said, there are cases where one person can see the UFO and the next person can't.
Yes.
Yeah, and that's kind of what you're getting at here. Like if 10 people see, and he said they could be standing next to each other. And then, Gary Nolan told me of a case later where he said people were in the same car and they saw completely different shapes, but it was, some object in the sky. One described, I forget the exact, one was a cylinder, one was a donut, but they were right next to each other, like when they were looking at it. And so this gets to this idea that are they projecting into our reality? So the case that Jacques told me about that was really interesting to me was in like Northern California or Oregon, like in the Pacific Northwest. If you've been there, there's all these tall trees, the redwood trees, those types of trees.
That's where he's from, Santa Cruz.
Oh, yeah, Santa Cruz.
Yeah,
okay. Yeah. And so he said he went to investigate this case where the witnesses claimed that a UFO had landed in this kind of clearing in the woods. And they also said that it had come down at a 45-degree angle. And so I guess MUFON and other people were investigating it, and Jacques was there. And Jacques likes to spend some time with the witnesses, usually over multiple days if possible, and get to know them a little bit.
As any good alien overlord should.
Right.
Just kidding.
But so, he after the other investigators has left, he goes, there's one thing I don't quite understand about, what you've said, is that you said it came down at a 45-degree angle.
Would have had to go through stuff.
It would have had to go through the trees, the redwood trees in this case, yeah. And yet you said it was a physical thing that landed here. And so I started to think about it, and they said to him, yes, that's true. But we didn't want to say that because we'll sound crazy, right? So if you take a purely materialistic view, that shouldn't happen, right? You shouldn't be able to go through trees and walls necessarily without cutting them up. But if you take a more of a projection approach, it's very easy for, like in a video game, you're resing something, right? You're rendering it, and while you're rendering it, you can de-render it. You can go through objects, but then when you render it, it becomes very physical from the point of view of the people in that world. You can't walk through walls at that point once your avatar is rendered there, because now the physics engine kicks in. But there are ways to have states which let you go through the walls and do all of these different things. There's also what we call conditional rendering.
Conditional rendering.
Yeah, so this is very common in video games. So let's suppose you and I are standing in a field, okay, and you're level, say I'm level 2 because I just started, okay, and you're level 25 because you've been playing the game for a while. And you'll look up and say, oh my God, look at that dragon. That's so cool. And I'll say, I look up and I don't see a dragon. There's nothing there. Because perhaps you acquired that, the ability, the spell to perceive, magical beings, let's say. And my character doesn't have that yet. The fact is we think we're looking at the same thing, but we're not. Each of us is rendering the game on our own quote unquote device, right? On our, okay, we're doing this in person, but if we were doing this on Zoom, yeah, we wouldn't actually be talking to each other, right? I would have been talking to my computer.
That's right.
And the bits would go to your computer, and then it would basically play my voice for you, but it would feel like we were talking to each other.
A little,
right? But similarly, if we're both in the same field, it feels like we're in the same place, but we're not. The rendering is actually happening in a distributed way. And it's happening.
What does that mean?
Meaning on your computer and my computer separately, right? So we're not necessarily seeing the same things. We don't know that. We think we're seeing the same things because I see your avatar and you see my avatar, but you may see a UFO and I may not see a UFO. So conditional rendering means, the ability to say on the server, okay, this person has the ability to see this. So render it on their device. Just like if I had a virtual background in Zoom, right?
Yeah.
Like that could get rendered for you on your computer, but it doesn't have to be rendered. I could have different virtual backgrounds for every person who's seeing me.
Is this like genetics in this case?
No.
If we're relating it to what we do, so I let me extrapolate. I may genetically have something in my brain that allows me, I don't know, I have a third eye and I can see this stuff, whereas you may not. And that may make me level 25 versus you being level 2.
Yeah, well, I'm not saying what that is. That could be from genetics. It could be your character. It could be a skill. Could be somebody who's had a near-death experience who suddenly has all these strange psychic abilities.
Thank you guys for checking out this clip. If you haven't already subscribed, please subscribe and hit the like button on this video. It is a huge, huge help. And if you'd like to check out this clip's full podcast episode, that link is in the description below or right here. And finally, you can follow me on Instagram and X by using the links in my description below.